Hello and welcome to the Learn via elearn.com classes. So in today's class we will see BFS program. Alright. So in my previous class I have explained you the algorithm and the concept about how BFS work. In case you have missed my class, please go through my previous class where I have mentioned it's the graph part 2 class. But before writing a program, let me give you a brief introduction of what I have explained you earlier, so that it will be good for you if even you have missed my class, right? So let me start with designing or drawing first graph all the vertices and edges that I am going to demonstrate in my program. So let's say these are some vertices which has been connected by some edges, like this way. Okay, and like this. Okay, this is my A vertex, this is my B vertex, this is my C, this is D1, this is E, and this is F. Okay, so how BFS works is, let me open a Excel sheet first. Alright, so we have basically two things here. Number one is we need to mark all the vertices which we have visited, and in BFS we follow queue concept. Okay, in DFS we follow stack, but here in BFS we follow queue concept. Okay, so this column is for those vertices which we have visited, and Q is column for those column which we have visited, and we remove a column one by one, which we remove all the vertices one by one which we have already visited, and finally when my column is empty, that means we have visited all the vertices. How it's going to happen? Let's see. For example, uh, A is my first vertex where I am going to start my breadth first search. Okay, so A is my root vertex. Okay, let me mark it in a green. Right, so A is my first vertex, and from here we will see how many other vertices are been connected. So from A, B vertex is been connected, so I have marked B as a visited. Let me marked vertices which has been visited as a B, as in some different color, for example red color. Okay, so this is vertex which I have visited. Okay, and I will put it in a queue. Okay, team, hope everyone know the concept of a queue. Queue is first in first out. That means the first which is been inserted will be the first which has been um, out, which has been pull out. All right, so from A we have visited from to B. Okay, now after marking it as a visited, let's move to C. Okay, next vertex which has been connected with A is C. Okay, let me mark it in visited and put it in a queue. Similarly, I have moved to D and put it in a queue. Okay, so my all the vertices of the first level which has been connected to A is visited. Okay, so uh, all the vertices is been visited. Now to move forward we need some another route. because my first root, which is A, is already covered. Okay, all the vertices which is been connected with my first root A is already covered. We have already visited. Okay, now we need another root. So as per the Q rule, we will first take that element which has been first inserted. Okay, so in our Q, my first vertex is B. Okay, so we will mark B as a root. Okay, and remove it from the Q. All right. What I do, I will put it in a black so that it will mark it is look like as a it has been removed. All right. Now see what other vertices is been connected with B. Other vertices are E and F. Okay, so let me mark E as a what, as a visited. Okay, as a visited one, E as a visited, and put it in a queue. Similarly, F as a visited and put it in a queue. Okay, now there are no such element which is been connected with B. So B is also completed. Now we need some another root. Okay, let's see our C vertex. Okay, so I am considering C as a root one. Okay, so remove it from the queue. uh, how many vertices are been connected with C? We have only one vertices, which is A, but A is already visited, marked as a visited. Okay, so this A is not being visited again. Team, all those vertices which is been visited already is not be visited again. Okay, we visit any vertex only once. So C is also done. Now let's go to another vertex. So in Q, another vertex is D, right? So we will mark D as a root and remove it from the Q. Okay, so let me mark D as a root, and we see how many other vertices. We have only one vertex, which is A, which has been connected with D, but A is already visited. Okay, we will see in the visited list A is already visited here, so there is no such element. Now move to our next element in the queue, which is E, right? So our next root is E. We will see the vertex which is been connected with B, which is with E, which is B only, and B is already visited. Similarly for F. So all the element which is been connected with FR, which is B only, is visited. In this way, we see all the elements in the queue has been removed, and we also see we have traversed the complete graph. Okay, we have traversed all the vertices in our graph. Alright, we have traversed A, B, C, D, E. We have traversed all the vertices. So this is the basic concept of how BFS works. Right, now try to execute this logic in our program. Okay, so let me open our compiler Turbo C and try to write a program. Okay, so first of all, let me include the header file. Oops. Okay, our basic header file stdio.h and a conio file. Okay, and then I need to declare some variable. For example, we need a variable called as a cost, which is nothing but actually store the value of my matrix. Okay, we need some variable like ijk n, and one more I need a variable for q, which is an array type, and for q I need a variable called as a front. Obviously there must be a rear. Okay, then I need a v variable which is for uh, vertices. I need a variable team, since I have already made a program, and I know how it works. That's why it's easy for me to understand the meaning of every variable. In case you are going to write a fresh program, so it will be recommended to make variable uh, as you go, right? Means just a second, VISITED visited. I need an array of my visited. Okay, okay, here and here, right? So these are some variable. I guess I have covered every variable here. Anyway, if I required some more or something I have assumed extra here, I will remove it, right? So let me start with our main program, and under that start with integer type of variable, for example m. Okay, what's the use of this m? We will see. I'm going to write a CLR SCR to make sure the screen is being cleared every time, and make sure this CLR SL should be written before printing of any statement, right? Enter the number of vertices, right? Actually, on the very first part of the program, we will ask some input from the user, that what are the vertices we are going to uh, traverse. Like, before understanding you the concept of BFS, I have made this graph, right? So in a similar fashion, we will ask some input from the user about the graph. Okay, and on that basis we will traverse the graph, whatever be the algorithm, either it's a BFS or it's a DF. Okay, so we will see, uh, we will scanf, I'm sorry what I'm written, percentage D, comma ampersand n. This is to store my vertices, and for edges enter the number of, I need one more variable, scanf, percentage D, %m, right? and then I want user to print uh, edges in this way. First a number, then space, and then n. Okay, so this will give him a understanding of how you need to write. Okay, now we need a for loop. The reason behind why I am writing this for loop is I want to store all the values which is been inserted by user for these edges. Right. So I need to start a for loop and store the all the values. Right. So percentage d, percentage d, then ampersand I to store first value, ampersand j to store my value of second edge, semicolon. Right. So this is about my storing of the edges, and let me store these values in a matrix also, and we will store this in this format. This should comes after this. Okay, team, I'm going to explain every statement, but before that I would like to finish this first. So here, team, it's possible for me also to write all this program, I mean earlier also, and I just explain you the how is actually work, but I won't prefer that because I want you to first of all see how I am writing this program, and secondary I would prefer to explain you some things, what and how and why I have using some variables, some concepts. So that's the reason why I always prefer to write. Okay, so here I ask a user uh, to let us know what's the initial vertex, means from which vertex user want to initialize his traverse. Okay, and after that we will print all the vertices which has been traversed. All right. uh, so what I did as of now, let me just explain you. See here, I basically want input from a user to know the number of vertices of the graph and the number of edges of the graph, and then I want user to print the number of edges so that I know which edge is been connected with which vertex. Okay, and I have stored this value in a IJ format and stored it in a matrix format also. Okay, now I want a user to let us know from which vertex he want to start the traverse. Similarly, in our example, we saw our root node. So this is basically I want to know the root node. Okay, like here my root node is A. So I will uh, ask user which is my root node, and then we will finally print the all the visited vertices. Alright, so now I want to declare my first vertex as a visited one, and also initialize a variable case with 1. We will see why. Okay, and then I want to start a while loop, and under that I want to start a for loop also, which will execute till my n input is smaller than or equal to j. I'm sorry, greater than or equal to j. Right? Oops. Then if cost of v comma j is not equal to, team, I will explain you this all logic, right? So in case you have any doubt, just please bear with me unless uh, let me finish this first, but try to understand what exactly I want to do here. But in case uh, you have some doubt, just let me finish this. It's almost done. Okay, I know sometimes it's happened that we want to understand the things, and since this program is written by my side, so it will be hard for you sometimes to know what exactly I am going to write next, right? But yes, once I complete this program, you will be understand each and every line for sure, right? I will repeat again and again to let you know or to understand you the concepts, right? So don't worry about anything in this program. Everything will be clear for you, right? Actually, there are few things which I really want to you know show you. For that I will prefer to use debug watch window, and then I would like to printf percentage %t comma v, and then a plus plus. Okay, visit v equal to 0. Okay, and then visited v is equal to 1. Yeah, okay, and then I will close my while loop. Okay, and then finally I would like to printf since my program is done, so I want to print press any key to exit. Right, so yeah, and I also want to stop my program for some time. Okay, unless I press any key. Alright, so I want get ch and then I will return 0. Let me try to compile this. Oops, I have 4 errors. Statement missing semicolon. Okay, so here I need to put a semicolon. What's next? Print FO, typo mistake. Print F. Okay, main cannot return a value. Okay, so since I'm using void, so no need to return anything. Next is unexpected curly braces. Okay, so why saying unexpected? Let me see. This is my first curly braces is started here, second is start here, close here, third is start here. Okay, this and this is been closed, this and this is closed. Okay, this is my while loop. Oh, okay, void main, and okay, yeah, this is my extra one. This is for my while loop. Okay, and this is for main. So yeah, all right, so let's try to understand this program, right? uh, I'm going to explain you every statement here, everything line by line, right? So one more thing, we need to make a adjacency matrix also, right, of this graph. So first of all, let me create an adjacency matrix. So we have A, B, C, D, E, and F. All right. Oops. And we have A, B, C, D, E, and F. Right. So as I've explained you earlier in my previous video, how to make an adjacency list. So let's fill it out first of all. So it must be 0 because there is no link between A and A, right? But yes, there is a link between A and B, right? Then A and C, yes, A and D, yes, and then it's 0 and 0, right? Similarly, there is no link between B. No, sorry. There is link between B and A. Here it is 0. B and C. There is no link between B and C. In fact, oops, there is link between B and E and B and F. Okay. See, B is connected with A, B is connected with E, B is connected with F. So basically, we must have 3 ones here, right? B is connected with A, B is connected with E here, and B is connected with F. C and A, yes. C and C 0, no. C, C and B, no. C and C, no. C and D, no. C and E, everything is no. D and A, yes. There is a connection. Okay, and rest everything is 0. Right. E and A, no. E and B, yes, and everything is 0. Right. F and A, no. F and B, yes, and there is no connection between any other element, so everything is no. So this is my adjacency matrix of this graph, right? This is going to help in our program. That's why I have created it. Okay, now let's see our program. See, I have now. Okay, so I'm going to use window watch to understand the program. right? So I am just pressing F7 key, right? So here my program gets started. Now on the very first time it's asking about enter the number of vertices, right? So how many vertices we have 1 2 3 4 5 and 6, right? So we will enter 6. After that it's asking enter the number of edges, right? So how many edges we have? Let's see, 1 2 3 4 and 5. So we have 5 edges. So I will write I have 5. Right, now it's saying print in the form of n edge n, and is store the number of edges in m variable. So this loop will continue 5 times, right? And it scan all the data and stores in a matrix, right? So my first edge is connecting between 1 and 2, 1 and 3, and 1 and 4 respectively. So I will write 1 and 2, right? Again it says okay, 1 and 3, again my third is 1 and 4, right? So I have connected A with B, A with C, A with D. Now I need to connect B and E, B and F. So that's why I will write 2 and 5, 2 and 6, right? Now see, I am just pressing uh, F7 key. Okay, one more thing, let me open this watch window, right? I have just pressed Alt W W, right? Alt W is for window, right? And inside this here is watch. See, team watch window is basically to uh, debug your program, and you will be getting all the exact value of that variable, which is I mean on a runtime basically, right? So I have just pressed enter, and here uh, let's see what's the value of n. Using down key I'm selecting another variable. Another variable is my m. Okay, now I want to see what's the value of k here. K here is as of now is 4, right? So these are some variable which I have used so far, right? We will add some more variable as we go, right? So where are we? Okay, so now I have just pressed one more. So here my next vertex is what, 2 to 5 and 2 to 6. So I have written 2 5 and sorry 2 to 6. Okay, so I am done with all my graph connection, so it will go outside. Now it's asking to where you want to initialize your vertex. So in my case means which node you want to be marked as a root, in another word, right? So here in my case it's 1. So it's like I am writing my first vertex is 1, right? Now see what happened. Alt W W, right? I am writing V also in my debugging list. So these are some variables which I am going to debug. We will add some more variables if required, right? So as of now is printing vertex V, because we are saying we have already visited vertex V, means my first vertex. Okay, remember this condition where we have traversed the complete queue and marked all the routes as in all the vertices as in visited one, right? So I will explain you again here, it's not an issue. Okay, as soon as we go with our program. Okay, so as of now we have marked V as an visited one. V means one means what? Our A vertex. Alright, now I am just pressing F7. So here in a visited array we have marked V of this array, means my first element which is 1 is marked as a 1, means we are not going to traverse this vertex again, right? After that I am inside the while loop. I'm going to going inside the while loop, and this while loop is basically for traversing the complete graph, right? So I am checking or I want to run this graph unless and until my complete node is been visited, right? So here I am checking if the value of k is smaller than n or not. N is what? N is my, see, here I'm storing n as an vertex, means when this vertex is greater than k, or k is I mean when this conditions fails, that means I have visited all the vertices, right? To make sure that we have visited all the vertices, I'm using this while loop in another word, in short form, right? Okay, so let's go inside the for loop. Now here I am initializing a for loop, and this for loop is basically for mark the all the vertices which is been visited to 1 and increment the value in q, right? See, team, as of now, let's say for example, uh, just a second. Okay, for example, my we have two pointers. For example, this is front, this is rear. All right, so as of now my front and rear is pointing to this position, for example, right? So I want my rear to be incremented continuously, right? As far, I mean, as my q goes increases, my rear is also goes increases, and in case I want to remove some element, I will I will increase my front value. Okay, I mean, how is going to work, we will see in a program, right? Okay, so now here let me open window watch. Yeah, so here after this for loop, I am checking a condition, and condition says, just a second, let me, okay, so condition says if cost of v and j, okay, see, v and j, what's the value of j here? By the way, j must be 1, right? Because here we have initialized it. Okay, let me put it in a window watch. Okay, so it's saying if the cost of vj, right, is not equal to 0, let's see in our matrix, means in another word is saying if the cost of 1 of 1, right, 1 v and j is 1, if the cost of 1 is not equal to 0, 1 of 1 means first row first column, means this value is talking about this value is not equal to 0, no, is equal to 0, that means this condition fails, right? So if this condition fails, since we are using AND condition, so it hardly matters if my other condition is been qualified or not, right? Let me show you some the rest of my condition which we have written. We have written visited as well as visit. So it's saying visited is visited j. Okay, so the value of visited j is not equal to 1. Okay, let's move upside. So visited j. Okay, as of now we have not set any value of visited j. Okay, let's see, just a second. No, we have set. See, here we are saying visited of v, and we have already marked this visited one as a 1. Okay, means my first route has been visited, right? So this condition also fails, right? Similarly this condition. Okay, so that means this loop is not going to work in my first case. Okay, now I'm pressing F7 and next time. So mind, let me, yeah, all right. So I'm pressing F7 key one more time. See, mind this value. You see, this value goes changes, right, from 1 to 2. Now I am at v of j. That means v is 1 and j is 2. Means I am talking about which element? First row, second column, means this element. I am going to check if this value is not equal to 0. Yes, this value is not equal to 0. And it will go inside. Okay, so what it will do? It will simply visit uh, the route where j is pointing. Means I am talking about this vertex. It will visit my second vertex b and marked it as a 1 because I want to mark b as a visited. Okay, and then what? Enter it in a queue, right? So as I have explained you earlier, I am putting my b value in a where, in a first, as a first element of my queue, right? So my rear is pointing. Okay, now my first, see, and what next I did, just go as per my program, and I am pointing my rear to plus plus, right? So in case my queues is starting from b, so let me mark here, and I'm putting r, let me put it in a capital way. Okay, okay, so my rear is pointing to this place, means my next element will be inserted to my this place where my rear is pointing. Okay, so I have incremented my rear uh, rear place where my rear is pointing, right? So we have incremented my rear part of the queue. Now see what our next loop. Okay, here I am just marking b. Now the value of j is 3, means I am talking about this element, first row and third column, right? So again this condition qualifies, and it will insert my c vertex also, right? Means I have inserted my c vertex where my rear is pointing, and again I incremented r value, right, and marked c as a visited, so that this, let me remove this also, so that this vertex will not be visited again, right? See team, is the same process what we have followed when I have explained you this graph, right? Alright, so let me press F7 again and see if the value of j is 4, right? So That means I am talking about this element. Okay, now here again my condition satisfied, and it's I mean I'm going inside the loop and marked j value, means my which value, which element, my d element is as a visited, and put it in a queue and incremented the r, right. See, it's incremented the value of rare, right. So this is how we have visited all the elements and put it in a queue. Now again, when I am uh, when I am coming outside this loop, the value of j is 5, means first row and fifth column, so it's a 0, this condition fails. So this will, this control is not going to go inside, right. So again mark this value, mind this value of j. I am just going to press F7. See, control is not going inside of this loop, and it will increment the value of j, and going to check if the value of j is uh, is not equal to 0 or not. I mean this 1 of j means 1 of 6, means this is I have visited. See, this condition means first of sixth column is not equal to 0, no, is equal to 0. So it not it will not go inside the this loop, if condition loop, and it will go outside of this loop. See how, right. It's very simple. See, team is very simple to understand. We are, see, what basic logic we are using. Let me explain you once again. I am just marking the all the vertices which has been visited as a 1, put it in a queue. Marking as a 1, put it in a queue. We are I mean I'm using the same logic which I have explained you earlier when I was when I was explaining you the BFS graph. I am just marking all the element in a visited list and put it in a queue, right. Now what I did last time, once all the visited or all the vertices has been visited, I am marking my most left part of the vertex as a root, right, and we visit all the vertices from the from that root, okay, and we remove this vertex from the queue, right. Remember I marked this BQ as in black, okay, so that it will marked as an DQ, okay. I have removed this this vertex, okay. So this is that's what I am going to do this here. I am marking V where my front is pointing, right. Let me open watch window, right. So what I'm doing, I'm just incrementing the value of front and put the value in V, okay. So where is my front, where my front is pointing to B. B means what? B means my second vertex, right. So as I pressed F7, my front is been incremented, right, and the value of V is 2, right, means I am printing my second vertex which has been visited. Remember we have printed V earlier also here, where when I was printing 1 means I have visited my first vertex, right? Now I am printing 2 means I have visited my second vertex, right? Right. So what we did, we have just incremented uh, front value means now my front is not pointing to B, it's pointing to C. Alright, let me remove it. Okay, let me include this variable also. Why not? FRONT front value. Oops. FRONT. Okay, so let me. Yeah. So what we oops, I have just pressed yes. So let me, how many vertices we have? Team, I have just pressed. I have just made a small change, and after that, its program is asking to rebuild it. I pressed yes mistakenly. I should have to print. I have to press no basically. But anyway, let me go up to that point quickly. So we have 6 vertices and 5 edge. My first is 1 and 3, 1 and 4, then 1 2, 1 3, 1 4, then 2 5 and 2 6. Okay, 2 5 and 2. Oops. Team, see, I have just modified anything in case I'm modified anything in our program, so it always asks to rebuild it. I need to press no because I want to continue from there. So 2 and 6. Alright, so we have entered 1 here and we have already visited. Yeah, we are here. Okay, now here if I see the value of front, it's 1. That means what? That means uh, uh, the value of V should be uh, the value where my Q of front is pointing. So earlier my Q of front is pointing here, right? Remember, let me undo it, right? And it's pointing to B, and where B means what? V means my second vertex. So the value of V is, that's why the value of V is 2. Okay, so we have visited first vertex, we have visited second vertex. After that we have incremented the value of value of k, means now we want to run my while loop from second, right? Okay, now after that we reset the value of visit to 0 and visited and marked visited v as a 1, means visited v, the value of v is 2 here, right? Means I am marking my second element as a visited one, right? So team, what we did as far as now, we have marked visited A, we have marked visited B. Now I am going to traverse all the vertices which has been associated with B, that is E and F. See how now it's checking if 2 is smaller if 2 is smaller than 6. Yes, it again go inside, right? Now what happened, it will check if cost of V and J, cost of V and J means cost of 2 of 1 means second row first column is this value. If this value, I'm talking about this value now, if this value is not equal to 0, yes, it's not equal to 0. Okay, if visited J is not equal to 1 means it's checking if the vertex has been already visited or not, right? So this value, this uh, means if the vertex has been visited, then we will not going to visit it again. Okay, so this been 2 is been already visited. Okay, so we are going to check our, I have just pressed F7, so we are going to check our next node, which is what, uh, V and J means 2 of 2, means 2 of 2, right? This node, is it not equal to 0? No, it's equal to 0, condition fails, right? Now I have just pressed F7, 2 of 3, is it not equal to 0? Yes, it's not equal to 0. This also fails. See here, it's 4, means I'm talking about this element, 1 2 3 4, 2 of 4 again fails, 2 of 5, yes, I'm talking about this condition satisfies because this element is first not visited and the value of V and J is not equal to 0, means this 1 is go inside. Mark uh, this vertex as an 1 and put it in a queue and increment the value of q, right? So my fifth element is what, E, marked as a visited, put it in a queue, right? Similarly it will work for my next vertex also, again it's go inside, means what's the value of J here, 6, my sixth element is F, put it in as a visited list and mark it in a queue, right? My rear is pointing here. Okay, we have already removed B. Okay, my front is pointing to C as of now. After that, once uh, this uh, this loop goes done with all the vertices, it will go outside of this loop, right? And mark the value of V where my front is pointing, right? So what's the value of front here as far as S1? Okay, so it's printing my vertex which is uh, pointing at Q of front, right? So as far as front value is 2, so it will print what, let me press alt F5 to see, it will print 3, right? Why? Because see, print V is what, where Q of front is pointing, right? So my front is pointing to 2. Okay, so 2 is what, this is 1, this is 2, 2 is where my front is, where my C is, and C vertex is 3, so that's why it's printing 3. Okay, and again we will reset the value of visit to 0 and mark visited V, means visited of 3 vertex as a 1, means I am marking C or also as a visited vertex. Alright, so in this fashion we will move forward to execute my complete graph, right? again it will increment the value of k, check for the vertex which has been visited, and if the vertex is visited it will not go inside the loop, and in the similar fashion it will move forward for all the vertices, right? It will mark the vertices in a visited graph. See, this is the basic logic. It will mark the vertex in a visited graph, it will put it in a queue, increment the value of r, so that it will, in case of any other vertex of want to add in a queue, right? And once all the vertex is been visited, it will increment the value of front, right? So that my front is pointing to my next vertex, and in that way we will dequeue the first element, right? That means first first element of the queue. Okay, so this is the basic logic what we are going to do this in our program, right? So if I just press F7 key continuously, see, we have visited all the vertices here. 1 2 3 4 5 6, we have 6 vertices and we have visited all the vertices. And in the last, if I press any key, it will go outside of my loop, right? So in this way we are done with our BFS programming. Okay, it's very easy, only you need to understand the concepts. It's very easy. I have made this program in a very one of the simplest format, so that you can understand the basic concept. And I would say, just I'm posting you this program along with this Excel file and this MS Paint sheet. So you try to make some another graph and try to understand this program and see if the result is coming as per your understanding or not. You can use window watch by pressing Alt WW and monitor each and every variable, right? So in that way you can see how control works. Alright team, so this is all about our BFS program. Alright, do as much as practice you can, and feel free to mail me to my email ID, which is learn@learnbylearn.com. In case you have any doubt in this program at any place, just write down to my mail, or uh, you can contact me on my Skype ID also, right? Someone will assist you, me or my team, right? But I always prefer to see all your queries in mail first, right? I always says, because it might be I mean, if you call, maybe, or you I mean, it's due to we might be in a different time zone, or maybe I was making some videos, or I'm in mid of the online classes and all. So that, I mean, it could possible that I'm not able to pick up your phone, or give that much of time. So I always prefer to see your mail first, and but you are always feel free to call me, right? So that's all about this BFS graph. uh, See you guys. Bye bye.